Hi, this morning I've been gearing up for my Learn to Solder classes. I figured I'd turn on the video and show you what I've been up to this morning. Um, in the past 5 years, I've mainly done little blinky circuit boards, either ones that I've purchased or ones that I've custom made. They either use transistor oscillators or 555 timers to blink LEDs on and off, and it's a good first project for people. But if you've been following my channel, you know that I've upped my game a little bit this year and doing some atTiny85 Arduino chip projects, a couple of them, and so this fall, I'm going to start off with this Tiny Simon uh, board. It's has a lanyard and everything, and they can wear it around their neck. And just a basic game that the Simon memory game, and um, runs off of a 3-volt coin cell, and um, uh, uses the atTiny85. And then as closer to Christmas, I've done a video or two on this board. It's the LED Charlie Plex LEDs and buzzer music Christmas songs. It's got 6 Christmas songs on it, and it also is using the atTiny85 chip on it. And so it's nice up in my game on it, but it also means a little bit more work for me with the 555 or the transistors. You just stick them in there and solder them. Of course, with the atTiny85s, you got to program them. So what we're messing with are these little um, just push in, socket mounted chips with legs on them, 8-pin chips with legs on them. And it's a little bit of a problem with them, but anyhow, it's I use this programmer here similar to this one, and as you can see, to program it, you got to put your uh, chip in that uh, socket there. And of course, if anybody's messed with ICs before, you know that they get a little bit delicate, and the more you push them in, and especially taking them out, you can get a little bit of a bent leg if you don't do it right. I have a tool over here, a 3D printed tool that I use for grabbing them and pulling them out, but it works pretty good, but sometimes it's not that great. So I have 4 local libraries that are going to take on my free Learn to Solder classes, have people sign up for them. So I'm probably going to have 50 people maybe, or maybe more this year, that are going to be doing this, and they're all going to be using the atTiny85. So I got to program at least 50 chips. I'll probably program a few more, but I decided that probably not the best way to go about it, having to pull all those chips out and make sure the legs are straight when I'm done and everything. So I knew about these, but I went online and I found these what they call zero insertion force chips. You put your chips in holes, and then you push this lever down straight, and it locks the chip in. And then when you're ready to take it out, you lift it out, and the chip will lift right out of it. There's no force holding it down. As you can see, this is actually for 16-pin chip, but I was able to get it to work with my 8-pin chip here. Here's my programmer with it. I just got it just stuck in there. It's it's the legs are just stuck in there temporarily. So, but it's been working for me, so I figured I'd do that. I do want to mention one thing about our chips. So if you know about the projects, so they are very different atTiny projects. So this one here runs on that coin cell. So it's 3 volts. It runs at 1 megahertz, and it has deep sleep on it. So there's actually no on off switch on this thing. When the atTiny85 goes into deep sleep, it uses almost no current. It actually, they say that the coin cell battery leakage just over time is more current than what it's taking. So I did have to finally replace. I've made these boards about a year and a half ago, and just before I started this video, I pulled this out, and the battery is finally dead after. But it's been a year and a half, and I've probably played with it a couple dozen times, and like I said, it just it only blinks a LED real fast, and has the buzzer, just a buzzer sound on it, and so it'll last for a good long while. But like I say, this is very different. It runs on like I say, 3 volts, low voltage, and deep sleep, and it runs at 1 megahertz, which is as slow as you can run the chips. By contrast, the Christmas tree, if you watch my video on this, I was concerned that it might use too much current, because you are limited to the amount of current that you can run through your pins on atTiny85, but I was just a little bit under, but it's up at near the max range on that. Also, to get the buzzer music and the Charlie Plex LEDs to work as well as they can, this chip is actually running at 16 megahertz. So you're programming it to be at 16 megahertz. So I wanted to show you a little bit of my process of how I did that, and how I program them. Like I said, if anyone is interested in learning more about programming these little chips or whatever, I highly recommend, and I will put a link to this Technobloggy blog, and it's a little bit dated, but it's still perfectly fine. He's actually updated, I think, down at the bottom. He'll say that he updated part of it for a new library that they found. But this was a wonderful starting for me to get started in them. By following everything in this blog, I was able to start programming them in very short time. As you can see, he updated this in 2019, so and then again in 2022. So like I say, it's updated for sure, so that's good. But I highly recommend that that you know, if anybody's interested in getting started with them, that's the place to be. Okay, so on to programming. So if you're done any kind of Arduinos before, you know, normally you just plug it in, and you just click the upload once you get your you know, your boards and everything. You go, and then you can just hit the upload, and it'll start uploading it. So when you're doing these bare chips, you actually have to go through a programmer. So under tools, you have to choose your chip, and right now I got atTiny85 or atTiny254585 with no bootloader. So that's another good thing about using the programmer, is you don't need a bootloader, because you know, you're not going directly to your you know, your chip's not looking for a program to upload. It's going through this programmer. You might have noticed that there was like a tail on this, and that's actually goes to the 6-pin ICSP or ISCP 6-pin port on your regular Arduinos or the Arduino Nanos, I most of the time, unless if I'm using it for a regular project, I'm programming them with this programmer rather, and without a bootloader. It gives you more space. Plus, if your project just starts up on power, you're not wasting that time 1 or 2 seconds when it's trying to go into bootloader mode, and it'll start up right away. Like I said, I used Arduino Nanos for my greenhouse controller, controlling our 1 acre greenhouse. And you don't, if you have a power failure and the power comes back on, we have a backup generator, but when that power comes back on, you want to start getting your information as soon as you can. So it's good to have that, no bootloader involved there. But anyhow, like I say, you're picking your choice. And then, like I said, on this one, this is for I've been programming our Christmas tree with the Christmas songs and the flashing Charlie Plex leads LEDs on it. And we're doing that at the 16 megahertz PLL. So that's what we've got that set at. I also, if you've looked at the video I did on that I disabled millis and micros, but you can actually get them a different way. This is actually the library, so it's disabled. And you can see the other settings here. So anyhow, the thing is when you change the setting or on a new chip that you get in, when you set your clock source, especially if it's internal, you want to go down, and once you put your chip in, first thing you want to do, even though we're not using a bootloader, you need to set what they call the fuses. And that is done when you burn the bootloader. Even though we're not using the bootloader, it's going to burn those fuses to let the chip know that you're using 16 megahertz. So I have to write that in my top of my program. As you can see, I got it written down up here. Must use slow ISP and burn the bootloader when you change your when you set that. So because if you don't do it, it's not going to turn out for you and everything. So you got that. So the first thing you want to do is make sure all these are set right. And like I said, they don't change on you as you change chips. And then you want to burn bootloader. And also, yes, I'm using the USB Tiny ISP, and we're using this atTiny core is what we're using. And I just use this slow one. You have to use the slow one if you're burning your bootloader. So I just use it. It doesn't seem to make that much difference when these little couple kilohertz or kilobyte programs that we're uploading to the chip. So that works fine. But once you have that, and like I say, so our process is that you got to burn a bootloader with a new chip, and then you go in, and instead of hitting this button, you got to go upload using using programmer. So I got a pile of chips here, so I'm going to go ahead and put one in. Actually, I probably didn't show you guys how this works, but let's see if I can show you. So you can just put the chip in here. Trying to do this, not seeing anything. So the chip's in there, and you can see it kind of just rocking around in there. You just hold it down with your finger, and you pull this button down, and now it's locked in, and it won't come out. The chip won't come out, and it's got good electrical contacts. And just as soon as you lift that back up, the chip falls back out. So yeah, so that's how that works. I actually got 4 of these for less than $10 off of Amazon, I think it was. So that's well worth it. I'm thinking that, like I say, right now I just got a jury rigged on top of my programmer, but I might end up maybe making a custom circuit board to hold that, so a little more stable or whatever. But let's go ahead and put a chip in here and show you the process of getting it done. And like I say, I'm gonna do this over 50 times. So I've probably done it 15 times already, so it's not too bad. So I'm putting a chip in and locking it down, and it's just in there. I showed you the process. So like I said, it's a brand new chip. We got to go here to tools, and we got to say burn bootloader, and that happens pretty fast. You watch it down here, right up here at the top, and it'll say what you're doing. Burning bootloader, and then done burning bootloader. So that's already done. So it's a two-step process. Once you do that, now you know that it's at 16 megahertz, and then you go in here and upload using programmer. And you can see it compiles the program like normal, and then it's going to upload it using the bootloader, and you can see over here, and it's done uploading. And you just remove the chip, and I got special pile, or I got these tubes that they came in, so I'm putting it back in there, and I'll take my label maker and put a label on there that these are programmed for the Christmas trees. Anyhow, that's mainly what I wanted to show you today and let you know what I was up to. Anyhow, thanks for watching. Have a great day, everybody.